Okay, we have our second circuit. It's the motor power or motor performance under varying loads. And so we have our dyno that we've seen before. We have our loading that we do on the left side here based on our dial here. And as we spin that dial load the motor, we're actually clamping a motorcycle brake pad to induce or infuse a load on the shaft to put that motor under load. And then we have over here, we have our varying voltage supply, which we'll talk about right here. And so this is my 0 to 100% voltage. And so I can vary that voltage on the motor to simulate varying load voltages based on varying voltage drops of our conductors. Then I have my voltage I'm reading at the motor and my current I'm reading through the motor. And then of course, I'll have a tach that I'm going to use to measure the speed of the motor shaft as we vary the voltage. So I'm going to run through a few of these just to show us how we would measure these values or these readings. You also have a document that shows all the detailed readings. This video is not quite the venue to go through every single reading with you. Also, if you recall, as I load that brake pad, it's going to induce some heat on that pad and it's going to start smoking. I actually was trying to go through all of them in one video until I saw the smoke kind of billowing out and I stopped very quickly. So I'm going to go through just 3 low, 60%, middle, 80%, and then a high 100%. And I'll give you the full breakdown, but I want us to watch and how we would do this. So as we turn on the voltage, this is much like we would have in a fan in an agricultural setting where we would vary the voltage being applied to the fan motor to vary the speed. And so if I vary the speed of this voltage, or this, if I vary the voltage, so here's my voltage at the motor, 18. I can see my speed slowly starting on the shaft. As I crank up the voltage, in essence, the speed is cranking up. And so it's hard probably to see it on the video, but I have my shaft spinning at a much higher rate the higher the voltage is. Okay, so that's actually a very common but crude way we actually can control the speed of a motor. We're going to look at this lab section to see that how the motor won't perform as efficiently with low voltages as the main reason, is the main way to control the speed. There's much more efficient ways, and our VFD is the most efficient to control the speed of a motor. But this is going to simulate our voltage drops. So we're going to start at 60. So I'll start here at 60, and I'll put my motor under load. So I now have the motor under load. It is under 1 foot-pound of load, and I'm running at 60% full load. So I have 84.4 volts when I apply 1 foot-pound of load to the motor. So I'm at 1 foot-pound of load on the motor, 60% volts, 60% of voltage. And I have a current now of 5.4. A voltage of 84.4 and a speed of 1750. So now I have my motor applied at 80% full load voltage. I have 112.6 volts. I have a current of 7.3, and I have a tap speed of 1768. So we're going to go up to 100%. And actually, at 100%, we're going to be beyond our 120. So this is actually all the way up to 140 volts. This is going to simulate an over voltage now situation where I'm above the voltage rating of my motor. It's going to spin that much faster. So I have now 137. I have a load current of 11.6, and I have a shaft speed of 1773.9. I think that's 1774. So there are our different voltages, simulating different voltage drops across the conductor, so the motor sees a different voltage based on variac dial. Then we had our different currents and, of course, our different speeds. So I'll post kind of a spreadsheet of all the different values across the 60 up to 100% full load. But that's at 1 foot-pound of torque on the motor, or load on the motor. Okay, so this is the second section of the lab, the load, the motor performance.